In the previous video, we mainly explained the basic usage of context and taught you how to achieve good results in ComfyUI using simple prompts. However, to take it a step further and achieve precise, pinpointed edits, you need to understand the core of using image editing models like Kontext, clear prompts that address three key questions: what to change, how to change it, and what to retain. The quality of the model's edits largely depends on how well these three questions are answered. Recently, the community has decoded Black Forest Labs' Kontext preset instructions, which include prompt generation rules for 13 scenarios. After thorough research, I summarized a prompt formula and tested it across multiple scenarios with different image input strategies, achieving excellent results. For instance, removing blemishes from a person in an image, making a model pick up an object, even if the model originally had something in their hand, referencing an item to generate patterned clothing and dressing the model in it. In today's video, we will comprehensively cover all aspects of the Kontext model, including the choice between the original and quantized versions, advanced prompt generation workflows using large language models, applications in scenarios such as outfit changes or e-commerce, and some useful LoRAs and plugins. Currently, there are 4 versions of the Kontext model: the Black Forest Labs original BF16 format, ComfyOrg's FP8 format, the GGUF format produced by Buhlerwinds and Quantized, and the recently released Nunchaku-accelerated version by MIT HonLab, available in FP4 and INT4 formats. In theory, the model quality ranks as follows: BF16 GUF-Q8K FP8 is almost equal to Nunchaku FP4. For 50 series NVIDIA GPUs, GUF-Q6K is almost equal to Nunchaku INT4 GUF-Q4K and lower quantized versions. Here are some recommendations for different GPUs. If you have a GPU with 24 GB or more VRAM, e.g. 5090 or 4090, go for the BF16 original model without hesitation. For GPUs with 16 GB VRAM, choose the GUF-Q8_K or FP8 model. For 12 GB VRAM, select the Q6_K model. These suggestions prioritize output quality. If generation speed is more of a concern, then the Nunchaku models are faster, typically doubling the speed. Note that for 50 series GPUs, select the FP4 format, while non-50 series GPUs should use the INT4 format. For smaller GPUs with only 8 GB or 6 GB VRAM, there are limited options. Using the 6 GB Nunchaku model is recommended, as it performs slightly better than the GUF-Q4_K version. Regardless of which version of the model you download, you need to place it in the Diffusion Models directory. Using GGUF models requires installing the ComfyUI GGUF plugin, and Nunchaku models require the ComfyUI Nunchaku plugin. As for the clip and VAE models, Kontext belongs to the Flux series and uses the same clip_L, T5_XXL, and Flux V. For those who have previously run Flux models, you likely already have these files. Without further ado, let's dive into ComfyUI and see how it works in practice. Open ComfyUI, make sure your version is updated to version 0.3.43 or higher. In the workflow template library, you'll see 2 context workflows. The first one is the basic version, which is composed of individual nodes. This allows full flexibility to modify all parameters and processes. I've created several workflows based on this one for different scenarios, and I'll demonstrate them shortly. The other example workflow is the group version. It simplifies the workflow by grouping multiple nodes together, making it look very clean. However, this comes at the cost of reduced flexibility. For example, you cannot set image output dimensions independently, use GGUF or Nunchaku quantized models, or load LoRA models. This version is more suitable for very simple and straightforward tasks. Today, I won't dive into these basic workflows. Instead, I'll start directly with the custom processes I've created. Let's load this single image LoRA workflow and run it. We get a fluffy textured little robot, and the results are excellent. The first part of the workflow deals with image preprocessing. Since context models work best within a specific image size range, this node automatically resizes the input image to the optimal dimensions for context. The interpolation algorithm used is Lanczos, and the cropping method is center. For example, if we input an image at 768 by 512, it will be resized to 1248 by 832. The model loading node by default is set to use the FP8 version of the context model. If you want to use a GGUF model, you'll need to replace this with the UNetLoader GGUF node. The node for loading LoRA models is still LoRA Loader model only, and I've selected a fluffy textured LoRA for this demonstration. Later, I'll show you other LoRA models that I find useful. The prompt here is just a simple phrase, make the object fluffy. For simple style transfers like this, complex prompts aren't necessary. Unlike the template workflows, this process uses the NAG plugin, which supports negative prompts. In this case, I've filled the negative prompts with terms related to low quality. In the conditional parameters, the only adjustable parameter is flux guidance. Theoretically, the higher this is, the more the output will adhere to the prompt, but it will also reduce the model's creativity and diversity. Generally, it should be kept between 1.5 and 5. In the image generation section, there are two sampler nodes. The default one enables NAG, which allows models like Kontext to use negative prompts. NAG adds 4 new parameters: NAG strength, nag_scale controls how strongly the negative prompts are applied. Higher values suppress undesired elements more effectively. This is usually the only parameter you need to adjust. NAG threshold, nag_tau affects the sensitivity of NAG triggering. NAG mixing, nag_alpha balances the influence of NAG and the original model guidance. Higher values make NAG more dominant, whereas lower values lean more toward the original sampling. It's recommended to keep this between 0.1 and 0.5, as higher values might destabilize the image quality. NAG termination steps, nag_sigma_n determines when NAG guidance ends during the sampling process. As mentioned earlier, the last 3 parameters are usually left at their default settings. However, do note that NAG significantly slows down sampling. I generated the previous image in 35.16 seconds using NAG. Now I'll switch to the standard sampler and retry. It only took 21.24 seconds this time, and I don't see a significant difference in quality. I think NAG is useful in 2 primary scenarios: excluding specific objects in an image, such as adding a negative prompt like realistic when converting an image into an anime style. Improving image quality when the raw results are blurry, by populating the negative prompts with terms related to low quality. For the sake of speed, I'll use the standard sampler for this demo. If you want blazing fast speeds, you can switch to the Nunchaku model. Simply change the model loading node to Nunchaku Flux-Loader. The parameters can remain unchanged. Since I'm using a 40 series GPU, I'll choose the INT4 version of the context model. Additionally, replace the LoRA loading node with Nunchaku Flux-Loader, and select the same fluffy LoRA we used earlier. You're ready to run it. One thing to note, while Nunchaku supports a wide range of LoRA models, not all of them are compatible. If you encounter an error, it means the LoRA model you've selected is not yet supported. The result is it only took 17 seconds, and the quality difference is negligible. Definitely worth using for faster workflows. Recently, the publisher of the context model, Black Forest Labs, launched a set of image editing presets using the context model. These presets include features like camera movement, relighting, hairstyle changes, movie posters, and more, making them highly practical. However, currently, these functionalities are only available for paid use on their official website. Soon after, though, forum user Race88 shared the system prompts used in 13 of these presets, enabling us to easily achieve the same effects locally. What are system prompts? System prompts are not prompts to be used directly with the context model. Instead, they are instructions provided to large language models, LLMs, such as ChatGPT, DeepSeek, Gemini, or Doubao. These prompts instruct the LLMs to generate the final context prompt based on the image you want to edit and your specific requirements. Let's take an example of an e-commerce product prompt to see how it works. At the beginning of the prompt, the LLM is assigned the role of a creative prompt engineer to craft an image transformation instruction for us. The subsequent explanation section details how the LLM should proceed. The goal is to produce an image resembling a professional product photo, incorporating a suitable usage scenario for the product, while considering aspects like the scene, lighting, and composition. Finally, the instruction specifies that the output should be a single AI-ready image editing prompt without any additional explanations. The other presets follow a similar structure. For example, in the movie poster preset, the LLM again takes on the role of a creative prompt engineer, However, this time, instead of a product usage scenario, you select a movie genre, e.g. action, comedy, horror. The LLM then fabricates a movie title based on the content of the image, adds a tagline, critics' quotes, a cast list, and more, ultimately creating a blockbuster-style promotional poster. Since these instructions were originally designed for the Kontext API, I made slight adjustments for easier local use. If you're interested, you can access them in the description. You can also create your own prompt instructions by following this format. But for now, let's test the goods and see how well it works. Open a chat window for a large language model. I'll use GPT 4.1, provided by GitHub Copilot, as an example. It's a multimodal model that can read image content. However, some models, like DeepSeek, cannot read images. In this case, I typically use Florence 2 to backtrace the image content first and attach the result as an image description to the system prompt. This approach also closely resembles how workflows are defined in ComfyUI. I pre-configured a backtrace workflow in this ComfyUI image environment using the Caption This plugin for image description. It loads the Florence 2 model provided by Nunchaku-accelerated. Load the image into this workflow, click Run, and get a detailed description. Next, open a text editor and paste the modified system prompt instruction into it. Below the image description, paste the backtrace result we just obtained. At the bottom, under Edit Instruction, specify the result we want. This can be as simple as stating a direction, e.g., place it in a kid's room. Copy the entire content into Copilot, and it will generate a context prompt for you. Now, return to the context workflow, upload the corresponding image and prompt, click Run, and wait. The result is perfect. I've also prepared a Chinese version of the system prompts for easier use. Now, let's try the Chinese version with a new scene. Simply modify the edit instruction at the bottom, e.g. change the kid's room to an airplane, write it directly in Chinese, and feed it to the LLM. The model generates another prompt. Run it in ComfyUI. And the result is just as impressive. As if the photo were taken mid-flight in an airplane cabin. If accessing Copilot is challenging for you, don't worry. These instructions work with nearly any large language model. Let's open the DeepSeek online chat page. The model here is DeepSeek v3. Both Chinese and English prompts work fine. Let's use the Chinese one and change the scene to a supermarket. The result looks fantastic again after running it through ComfyUI. With this setup, even if you're not adept at crafting complex prompts, you can replicate these presets to effortlessly produce high-quality image editing results. I've integrated these presets into a node within the MIE Nodes plugin. Let me demonstrate how to use it. Add the Context Prompt Generator node, which includes many preset options. For this demonstration, I'll use the Product Photography preset. Connect a large language model's API service. I'm using a SiliconFlow LLM service node to access the platform's model API. The plugin also includes a node for GitHub's free models, which feature GPT 4.1 and others. Alternatively, you can use the SetGeneralLLM Service Connector node, input an API and token, and connect to various platforms. If you encounter issues, feel free to submit an issue or merge request so we can support a new API platform together. Add Florence 2 related nodes for describing the image. It's best to fix the seed, as the description only needs to be generated once. Finally, I usually add a translation node to check the generated prompt's content. For the edit instruction, write something like place it on the moon. Click Run, and everything works perfectly, a lonely blocky flower quietly gazing at Earth from the moon's surface. Presets are more than just a collection of scenarios, they define a structured approach to writing prompts. The core idea is to craft detailed descriptions based on the content of the input image, specifying the object you want to transform, and predefining a scene. This provides the model with details about the desired result, emphasizing parameters like style, angle, and lighting. In contrast, the simple prompts we usually write lack detail, leaving too much room for the model to improvise. For example, when generating images using Flux, a basic prompt like a lady will struggle to achieve the same level of precision and complexity as a detailed system prompt. Following the same logic, I've created a system prompt for skin blemish removal, which works similarly and is included in the plugin. Let's test it out. I'll start with a photo of a young woman with noticeable freckles on her face. We switch the prompt instruction node to the skin spot removal preset. Since this operation doesn't require additional input, we can clear the Edit instruction field. Click Run, and the freckles are gone. However, the result shows the oily skin texture common to Flux models. Let me use a different image for demonstration. Here's a close-up photo of a man with more severe skin issues. Without changing any settings, I'll click Run. The output image looks somewhat plastic, doesn't it? To address this, we can enable the LoRA loading node and select a Kontext high-resolution face LoRA to enhance skin texture and facial details. This LoRA comes with a trigger word, though in my testing, I found it works fine even without adding it. Let's click Run. Whoa, at a weight of 1, the change is too dramatic. I'll lower it to 0.6 and run it again. This time, the result looks perfect. If we want to simultaneously send multiple images to Kontext for editing, we'll need to make some adjustments to the workflow. Let me demonstrate this with an outfit-changing workflow. Replace the first image with a model photo and add an upload image node for an outfit. Add an image stitch node to combine the two images into one. By default, the second image is placed to the right of the first image. Pass the stitched result to the Flux Context Image Scale node for resizing. Add a node to describe the second image using Florence 2. You can reuse the previous Florence 2 node to avoid reloading, and pass the generated description to the context prompt generator as the image description too. When editing multiple images, if one image serves as the primary focus, like in our case, where the person in the first image is wearing the outfit from the second image or holding the item from the second image, it's best to define an empty latent node separately, set its dimensions to match the first image. However, if you want to combine elements from both images, such as making the person in the first image hug a person in the second image, you can leave this step unchanged. Now, I'll change the instruction to change clothes and click Run. The result is in, the young woman is now wearing the t-shirt. The details of the outfit are well preserved. Let me try switching to a more complex outfit, like a wide strap dress. Since wide straps are relatively uncommon, they can be prone to errors. The prompts are automatically generated by the preset, which is very convenient. Let's run it and wait for the result. The final image looks great, too. However, in the area of outfit swapping, Kontext performs better at generating a model for the clothing in the source image rather than dressing a specific model in the outfit. For example, if I take this very complex outfit as the source image and ask Kontext to generate a model for it, the final result will look perfectly aligned. But when swapping the outfit onto a designated model, the details and proportions can easily distort. Additionally, Kontext has strict requirements for model reference images. Ideally, these should be full-body shots where the model isn't already wearing complex clothing. For instance, if your desired model only has a photo of them in an evening gown, this workflow might not produce good results. In that case, you could first use a clothing removal LoRA to clean up the model photo or use an image stitching workflow which I'll cover later to overlay the outfit onto the model before editing further. I personally find that ACE produces better results for outfit changes. Now, let's experiment with having the model in the first image hold an item from the second image. For this, I've swapped the images. In image 1, there's a model, and in image 2, there's a plush toy. Switch the preset to object holding and click Run. Oops, this seed was a bit of a fail. But since each run only takes 20 seconds or so, I'll try again. This time, the model's pose looks much more natural. However, this plush toy is a bit large. This highlights a major issue in multi-image workflows, especially when dealing with objects placed on a white background without references. The model struggles to determine the object's size. In such cases, it's often better to use a compositing workflow, where the object from image 2 is directly placed into image 1 and passed to Kontext as a single image. Let's load this pre-prepared workflow. Using the Layer Mask Segment Anything node, we extract the object from image 2. Then, we use the compositor node to merge it with image 1. After this step, the workflow continues as a standard context image editing process. Click Run. The workflow quickly reaches the compositing stage. Here, we can use the mouse to adjust the plush toy's position and size. Once satisfied, click Continue, and the workflow will proceed. For this, I've written a detailed and structured prompt based on the core concept we discussed earlier. The final output image demonstrates that the plush toy now has a much more proportionate size. There are many nodes available for compositing images. For instance, I previously introduced the Layer Utility Image Blend Advanced node in an e-commerce workflow. You can pre-process the images in a separate workflow and then pass them to Kontext. Returning to the multi-image compositing workflow, let's demonstrate another classic use case, face swapping. Keep image 1 the same and replace image 2 with a photo of another young woman. Use the image crop face node to extract the face from image 2. Next, as we did with the plush toy, use a compositing node to paste the extracted face onto the head of the original character in image 1. At this stage, the result might look quite jarring, but we can load a specialized LoRA overlay, which is specifically designed for situations like this. Switch the prompt to the LoRA's trigger word, place it, then click Run. The result is flawless, the face looks perfectly integrated. This LoRA excels at face swapping tasks. There's another similar LoRA called Put It Here, which uses a similar operation method. It works well to add accessories or adornments to a character, and the results are quite impressive. Kontext LoRA training is relatively easy, according to the experience shared by the creator of the skin high-resolution restoration LoRA, Significant Stop 1971, no caption is required. Training can be achieved with just 10 to 15 sets of before/after images. With this simplicity, he's shared over 20 different functionality-focused LoRAs. The community has also embraced their creativity, leading to the development of a wide variety of LoRAs, particularly for style transformations and outfit-related tasks. There are also many LoRAs with completely different functionalities, such as high-resolution restoration LoRA. This can upscale a 70 by 70 low-resolution emoji to 1024 by 1024, making an entire world appear in sharper detail. 360-degree LoRA. This transforms a regular image into a panoramic photo. If you encounter a specific requirement, it's worth searching to see if a suitable LoRA already exists. That wraps up today's tutorial. Let's summarize. Kontext is a highly practical model. To achieve better results, prompts are crucial. Using a well-structured prompt will yield significantly better outcomes. Preset instructions from large language models make the process more straightforward. Auxiliary tools like bounding boxes or masks can precisely modify specific areas of an image. Limit edits to one focused task at a time. Achieve comprehensive results through a series of consecutive, step-by-step edits. I've explored workflows including generating clothing based on specific patterns, applying it to specific models, and upscaling images in high resolution. While multi-image editing offers flexibility, it's less controllable and effective than single image edits. It's often better to manually composite images in advance. Lastly, there is a vast array of LoRAs available. When aiming to achieve a specific function, check if there's an existing LoRA that suits your needs. You might find exactly what you're looking for. That concludes today's tutorial. All the models, plugins, and workflows mentioned in the video are linked in the description. Feel free to explore them on your own. See you next time.